When you are installing pipe, you are going to encounter obstacles that you are going to need to go around. One way we do that is with an offset. Most offsets we deal with have two 45-degree angles and a 90-degree angle. On the slide, we have two offsets. One is a horizontal offset, the one on the left, and the other is a vertical offset, the one on the right. If you notice, both are exactly the same but for two words. Run is used for a horizontal offset, and rise is used for a vertical offset. The term offset is the distance that the pipe will be out of line. Looking at both the left and right pictures, you should notice the triangles. These are there to show that both the offset measurement and the rise or run measurement will be the same length. In geometry, this is known as an isosceles right triangle. Looking at the picture, we are dealing with a horizontal offset. If you notice, the line labeled B is going to the center of each of the fittings. This is called a center-to-center measurement. The line labeled A is the diagonal pipe we want to find the correct measurement for. When we are making the calculations to find the proper length, we first need to find the length that is needed to reach center to center of the fittings. To work through the equation, we will use constants for some of the numbers needed. Constants are given numbers that do not change. The constant for a 45 degree is 1.414. On the bottom of the slide, there is a chart that shows this number. It also shows that to find the diagonal, you must take the offset measurement and multiply it by 1.414. So if the measurement from the center of one pipe to the center of the other pipe is 8 inches, then 8 inches is our offset. We multiply 8 inches by the constant 1.414 and get an answer of 11.312. Since the pipe does not actually go into the center of the fitting, we next have to subtract from the overall length to get our proper length. If you look at the picture on the left, it is of a threaded 45. You will notice that it is measured from the center to the face of the fitting, which is labeled the A dimension, and it also has the measurement of the collar, which is labeled the B dimension. You will also notice there is a dimension G. In the chart under the threaded fitting, it lists the size of the A and B dimensions, but not the G dimension. To get the G dimension, you must subtract B from A. The G dimension is the number we need to determine the proper length of our pipe. Looking at the chart, you will notice all the different fractions. If you remember from math, you cannot subtract or add fractions that have different denominators. A denominator is the bottom number of the fraction. Let's look at the A and B dimensions for a 3/8 inch 45. We have 3/4 of an inch for the A dimension and 3/8 of an inch for the B dimension. The easiest way to subtract the B dimension from the A dimension is to change the fractions into decimals. We can do this by dividing the top number of the fraction by the bottom number of the fraction. For the A dimension, it would be 3 divided by 4, which gives us 0.75. For the B dimension, we would divide 3 by the 8, which would give us 0.375. Next, you would subtract 0.375 from 0.75 to get the G dimension. I showed you the work on the top left-hand side of the slide. What is nice about the copper 45 pictured on the right is that the chart below it gives you the G dimension. We have our diagonal center-to-center measurement, which was 11.312. And we have our G dimension, which is 0.375. The next step is to find the actual length of pipe we need. For this step, you will subtract the G dimension from the diagonal center-to-center dimension. When you do this step, remember you are using two fittings, so you need to subtract the 0.375 twice from the diagonal dimension. Remember, we have to subtract the 0.375 twice. So we end up with 11.312 minus 0.75, which equals 10.562. We then change the decimal back to a fraction by multiplying the 0.562 by 16, and that equals 8.992. We only use the whole number and not the decimal number. Since the number next to the decimal is greater than 5, we round the whole number 8 up to 9. Our final pipe length is 10 9/16 inches long. You might be wondering why we multiply the fraction by 16. We do this so we can get to the nearest 16th of an inch. You can multiply it by 4 to get the nearest quarter of an inch. We use 16 because it is the easiest small measurement to read on our tape measure. Let's go over the steps one more time. Don't worry about copying this down as I'm saying it. This slide will stay up, or you can just push pause and copy these down if you'd like them. Step 1. We're going to find the offset measurement, which is the center of one pipe to the center of the other pipe. Step 2. We multiply the offset by the constant 1.414 to find the center-to-center diagonal pipe length. Step 3. We figure out the G dimension of the fitting. With black pipe, A minus B equals G. The letter B is the threaded in measurement, or what is called the makeup. A is the measurement from the face of the fitting to the center of the fitting. G is the fitting allowance measurement, or the unthreaded portion of the fitting. Step 4. We are going to subtract the G dimension from the center-to-center diagonal pipe length. Remember, you must subtract the G dimension you found twice. Step 5. If you have changed any fraction to a decimal for easier math work, you must change it back to a fraction. You do this by multiplying the decimal numbers by a common fraction number you find on a tape measure. We generally use 16. As an example, if you had a decimal number of 0.656 and multiplied it by 16, your answer would be 10.496. We only use the whole number for our fraction. So the fraction we get is 10/16. This fraction can be reduced by dividing both numbers in the fraction by 2. Our final answer is 5/8 of an inch.